Stanford University.
Okay, well, welcome to lecture 17 of Stanford CS 193P, spring of 2016. This is our penultimate lecture that actually has content. Next week we have Memorial Day, and then we'll have an alternate final on Wednesday. So what are we going to talk about today? Today we're going to talk about segues. Okay, we've talked a lot about segues, but there's still quite a few more segues to be talked about. And then we're going to talk about core location and MapKit, which is kind of where is the device in the world. And then I'm going to do a demo. I'll do as much of the demo as I can, and then we'll just continue it on Wednesday. The demo is going to be about maps and segues. Obviously, that's what we're talking about today. All right, so let's dive right in here to segues. The first segue I'm going to talk about is the modal segue. So this modal segue is a segue to an MVC that is going to completely take over your screen, okay? You are fully responsible if you put a modal segue up for providing a way for the user to get out of it, okay? Because that MVC is completely in control. This kind of UI should be used with care, okay? Because you really are locking down the UI. There's nothing else the user can do. They can't, if they change their mind, they can't go to another tab, because it's not a tab bar thing. They can't just hit back in a navigation controller. They can't go to the other side of their split view or whatever. They're pretty much stuck here until you let them out of it. And so I don't even show you this until late in the quarter, because I really don't want you to think of this as a go-to way to present an MVC on screen, okay? But it does have its uses, okay? Here's an example. Perhaps, okay, this is a contacts app, or an app that has contacts in it. And we're showing the contacts, and the little plus button in the corner here, let's say that that button's going to allow us to enter a new contact. Now, you could argue if the user has chosen to enter a new contact, they don't want to do anything else except for that right now. And so it's okay to present this adding contact view controller modally. And modally just means in a mode where you can't do anything else but this. Yeah, one could argue there might be other ways to do this, but let's say that we're going to do it this way. So we tap on this plus sign, and from the bottom slides up this new MVC. Now this new MVC is completely controlling the screen. It doesn't have a back button. That cancel button that you see right there is a button that this MVC is putting in that bar. Okay, it happens to cancel and not add a new contact in this case. So this is not a push segue. This is a modal segue, different kind of segue. And the thing about modal is you can actually have embedded modal inside modal. Okay, so for example here I'm adding my contact. Let's say now I want to choose the photo for my contact. Okay, that's also going to put up a modal MVC to get that. So I click on that. Another MVC slides up from the bottom, so now I have two modal ones. And you might think of this as a little bit like, oh, navigation controller, they're on a stack, but that's really not the way it is. It's just the add contact MVC took over the entire world, and then it gave it to the photos one, and it completely took over the world. And until it's dismissed, the other ones don't even really matter, okay? Now, again, notice no back button here. Also notice, by the way, that cancel button has moved over from the right, whereas the previous MVC had it on the left. I'm not a big fan of this kind of UI, by the way. I think things like cancel, if they're conceptually the same thing in two MVCs, especially two MVCs that appear back to back like this, should probably be in the same place. So I would have put the cancel buttons both on the left here, but whatever app this is, from where these contacts came from, decided to do that. But in any case, no back button here, right? Make sense? Okay, so let's cancel this, and we'll see what happens to this modal MVC. This cancel is a way to get out of it, and when we cancel it, of course, it slides back out. And the other MVC is still there, okay? Nothing has changed. And here, of course, if we cancel this one, then we'll go back to where we were before, and this MVC goes away. So that's modal, right? You present the MVC, it lives, it does whatever it does, it completely takes over the app, and then somehow you press something to get out of it, to cancel or done or whatever, but that's totally up to that MVC. All right? So be careful, is all I say about this. Don't go to modal first. Think about whether there's a way to put it in a tab or in on your navigation stack or something like that before you jump right to choosing modal. All right, so how do we set up a modal segue? How do we do one of these? Just like all the other segues we've been doing, you just control drag from the thing that's going to cause the modal segue to happen to the MVC that's going to take over the world. When you do that, by the way, important thing to notice is that you can inspect the segue, and a modal segue has different kind of things you can choose, which I'm going to talk about, like how the modal segue is presented. Does it slide up from the bottom or do something else? And also, what does the modal segue look like when it's there? Is it a take over the full screen kind, okay, or is it some other kind? We'll talk about what those other kinds can be. All right. If you want to present a modal MVC not from a button, okay, or from a bar button item, you want to do it from something else, of course, you can present it using the normal perform segue with identifier from your code. We've seen a couple of examples of that in the demos, and of course, modal, you can do that as well. You also, if you have a view controller in your hand, you actually have an instance of a view controller, like remember alert view controller, right? You say new alert view controller and you get one. Now you have one. You can put it up using this method right here, which we actually saw in one of the other demos, alert demo there. Actually, I don't know if I demoed it, but we talked about it in alerts, which is present view controller. And you just give it the view controller that you have in your hand, and whether you want it to be an animated transition, which usually you do. And then it's got a little handler here at the end that will get called when it has finished being presented. You usually don't need that, but just in case you do. All right, so this is how you present something modally. This is only for modal presentations, all right, if you have the view controller in your hand, which is rare. Generally, it's things you got from iOS, like maybe the camera view controller or the alert view controller, some things like that. Notice that in horizontally regular environments, horizontally regular, not compact, there's a modal presentation style var in a view controller that will specify basically how this view controller gets presented when it gets presented modally. Does it get presented full screen, where it takes the whole full screen? Over full screen, which means it goes over the whole screen, but the one behind, whatever is existing on the screen, is visible. So if you had a clear view controller, you'd be able to see through it, see the things underneath. Popover, of course, you guys know what a popover is. Popover is just a modal MVC, but it's kind of got some special presentation characteristics. There's also form sheet and page sheet, things like that, which kind of present in different ways. You can play with those by inspecting the segue in the storyboard and choosing different presentation styles. Note that in horizontally compact environments, however, which is basically the iPhone in portrait, the system, when you do this present view controller, will by default adapt to be full screen. Okay? So if you try to present something in form sheet mode, okay, on an iPhone, it'll come up as full screen because it'll adapt to the fact that it's on a phone. It doesn't really have enough width to do a form sheet for you. Okay? How do you prepare for a modal segue? Nothing to see here, okay? It's just like any other segue you've ever done, nothing special about it. Just check the identifier, get the destination view controller, and prepare it. How do you hear back from a modal view controller? You put something up modally and it does something, okay? It adds a new contact. How do you hear back with the results of what it did, okay? Well, there's a couple of ways to do this. One is that the add contact thing might be putting the contact in a database, some model, that is shared by the guy who put it up. So then you don't need to do anything. Okay? When the modal thing gets dismissed, you'll come back and, oh, there'll be something else in the database that wasn't there before. Another way is using an unwind segue, which I'm going to talk about in a few slides here. And then another way is delegation. And the reason we have to use delegation or unwind or something like that is because when you present a view controller modally, it's part of your view. It's part of the presenting view controller's view. So that thing can't talk back in any way except for those blind structured ways we talked about, like delegation. Okay? How do you dismiss a view controller, right? So view controller's up and it's collecting the new contact and then the user hits cancel or done. How do we make it go away? The answer is you ask the presenting view controller to dismiss you. Always the presenting view controller dismisses you. All right? And you send it the message dismiss view controller animated to the presenting view controller, and it's going to dismiss whatever modal view controller it has presented. Okay? So that's sent to the presenting. I can't emphasize that enough. Now, in the old days, people used to send it to the presented. The API was a little bit different, okay? And they would send it to the presented view controller, the one that's actually up, okay? And that's wrong. For backwards compatibility, if you sent it to the presented one and the presented one had not presented another one, then it would dismiss it. But don't write your code to depend on that kind of backwards compatibility mode. When you want to dismiss it, you send it to the presenting. Now, the great thing is the presented has a var called presenting view controller, which is the view controller that presented it. So it's very easy for the presented one to dismiss itself by asking its presenting view controller to dismiss it. You see? But that's the way you want to write that code. Okay? If you do an unwind segue, again, which I'm going to talk about in a few slides, it automatically dismisses. So when you unwind, you don't have to call dismiss view controller. It just automatically dismisses. So we'll talk about unwinding in a second here. All right, so in addition to how the modal view controller appears, like form sheet or popover or whatever, there's also how it gets transitioned onto the screen, what animation gets used, okay? So cover vertical is the slides up from the bottom, flip horizontal, exactly what you would think. The presented and the presenting flip are like on two sides of a card and it flips over. You got cross dissolve, which dissolves between the two. Even partial curl, which will partially curl the presenting one up, showing the presented behind it, kind of just at the bottom. It kind of looks really cool. You see it sometimes with map applications and stuff. You curl the map up and there's something underneath. Okay? All right, let's talk about that unwind segue, right? You have these MVCs. They want to communicate back or they want to jump back. Maybe something's on a navigation stack and wants to jump back farther than just one pop, okay? You can do all this with an unwind. Now, unwind segues are weird because they violate the thing I told you was never violated, which is that segues always create a new MVC, okay? And that's generally true. If you modally segue or show segue or any of these other kinds of segues, it creates a new MVC every time, except unwind. Because unwind is going to segue back to somebody who presented you. Maybe not the guy who immediately presented to you, maybe somebody who presented the guy who presented to you, but you're going to be going back to an existing view controller. You're going to unwind, okay, your view controllers. What's it good for? Like I said, good for communicating back information after a modal one is done, and also good for jumping back up the stack of cards in a navigation controller more than one step, okay? Because it can go back to guys who presented guys who presented guys, so it can jump all the way back. How does it work? Okay, so instead of control dragging to another MVC to set up this segue, which is what you usually do, you actually control drag to this little button at the top. It's kind of reddish. It's the exit button. Okay, so if I have this row in this table right here, and when you click on it, it wants to unwind and go back to one of the MVCs that presented this MVC, it just control drag up to this little exit. Now when you do that, it's going to show you a list of methods that are implemented by other MVCs in your app. Okay, they're special, and I'll show you what makes them special, but these special things will appear in this list, and all you do is pick which one you want, and then when you do this segue, it will start looking up the list of MVCs that presented you, and the one that presented that, the one that presented that, until it finds that method. And it'll dismiss all the way back to that one and call this method. Okay? So let me show you some more pictures to make this a little bit clearer right here. So this go back method right here, okay, I connect it to exit and I have go back. Go back, let's say, is in the guy who directly presented me. He could be farther up the stack, but let's say he's right here. And here's this go back method right here. Now, what's special about this go back method in this presenter? Well, one thing is it has to be marked IB action. Okay, so if it has IB action. And the second thing is the argument has to be a UI storyboard segue. So any method that is marked IB action and has UI storyboard segue as the argument is going to appear in this list. Okay? Now, this IB action, once you kind of pick the one you want, this segue is going to happen, and it's still going to be a normal segue in that it's going to have prepare. Now, the prepare, okay, here's the prepare segue. It's going to be in the MVC that you wired the exit button up to, the one on the right here. Okay, so it lives down in there. And it gets to prepare for this segue. The segue is going to come back to this presenter. So the destination view controller here is the presenter. The source view controller, which you haven't seen yet in previous segues, is the thing on the right. Okay, the thing that's segueing from. So that's the source. This is the destination. Okay? Make sense? And when this happens, okay, when the segue happens, you'll be dismissed. Right? The source one will be dismissed. And again, it doesn't have to just go one level up. It could go up the stack of a navigation controller things, or if you had 4 or 5 modals in a row, it could jump all the way back. It's perfectly fine. It's just whoever implements the method. All right. Now let's talk about another kind of segue, popovers. Okay, you've all seen a popover. Here's an example of a popover here on the right. This is probably some kind of search for appointment popover. Okay, and so this MVC just lives in here, and it's being presented modally. Okay, it's just that it presents in a way that looks like this, okay, like it's in a popover. And the popover, of course, has a little arrow at the top, a little white arrow, you can see it, that points to the thing, the UI element, that caused it to pop up. Okay, usually that's a bar button item, but it could also just be an arbitrary rectangle inside some view somewhere. Okay, this area out here, okay, everywhere else except for this popover and the keyboard, is grayed out. If you click there, it will dismiss this popover. So the one difference between a popover and another kind of modal one is that popovers are easy to dismiss. Just click outside of them, you'll dismiss. So you don't need a cancel button in a popover, a modal popover. But it's still modal in that obviously you can't do anything in that grayed out area. You can only do what this search for appointment MVC wants to do right now. Okay, so still modal, it just looks different. Popover is just a presentation style, basically, for modal. Popovers, you think of a popover as kind of like a navigation controller, or a split view controller, or a tab bar, because it's putting a view controller inside another view controller, but it's not. You should think of popover just as a presentation style for modal. Okay? So segueing to a popover is set up the same way that you set up on a modal one. It's just that when you drag over, you're going to pick popover instead of modal. Okay, when you're in the storyboard and you drag over. Now, an important thing to note when you prepare for a popover segue. This is what's different between a popover and a modal in code. Okay, when you prepare, all presentations of any kind of segue are done by a UI presentation controller. You don't see this. I'm not really talking about this in this class. It's not really a kind of an introductory material. But the popover one has a subclass of that called UI popover presentation controller, and it's the thing that knows how to present as a popover. So it's the thing that knows, for example, where to have the little popover thing point. Okay, that's something that popover presentation controller knows about. So in your prepare for segue, you're going to get this UI popover presentation controller, and I'll show you how to do that. And you're going to use it to configure how the popover presents. Okay? Now, in addition to setting things like where the popover's arrow can point, you can also control things like how the popover adapts to different size classes. Okay? And we'll talk about that in a second too. So here's a prepare for segue, the prepare for a popover. Okay? All the green except for what's in this yellow if statement right here, is the same as any other prepare. But when we get down to the bottom here, we're going to get that popover presentation controller by asking the view controller that we're putting up modally, please give me your popover presentation controller. Okay, so that view controller has the popover presentation controller, and we get it. Once we have it, we can do things like configure it, like the permitted arrow directions, which direction we want the arrow to be. We can also specify things like where the arrow should point, all that kind of stuff. Okay, everything you would imagine a popover needs to be configured with. All right, now also importantly, we can set that presentation controller's delegate. Okay, and with that delegate, we control a little bit more about how the popover works. So let's talk about that. What can we do with the delegate? One thing we can do is find out when that popover was dismissed. Okay, so the delegate will be sent this message: popover presentation controller dismissed popover. Did dismiss popover. Okay, so that's nice to be able to know when that popover was dismissed. Another thing is we can control the adaptation behavior when we're in different size classes, like horizontally compact. Okay? So when a popover comes up, as you can imagine, maybe it wouldn't fit in a horizontally compact environment unless it's kind of a small popover. So by default, the system adapts to full screen. So if you have a popover segue and it's on horizontally compact, it gets changed to modal full screen. So it'll take over the whole screen, slide up from the bottom. Okay? Now you might not want that. Maybe it is a small little popover, and you do want it to be a popover on iPhone, and you can control that. And here's how you do that. There is a method. Okay, this is a popover. This is actually a presentation controller a delegate method, and you can see it just sends you the controller here and a trait collection. So that's the size classes right here. And you're going to return a presentation style. Now, if you don't implement this delegation method, then in horizontally compact, it returns full screen. Otherwise, it returns whatever it was set up in the storyboard, popover or form sheet or whatever. But if you do implement it, you could return, for example, UI modal presentation style none, which means don't adapt. This is asking for how do I adapt to this trait collection. If you say none, that means don't adapt. Just do the same thing on every single platform. Okay? And so if you do this, then your popover will appear as a popover on your iPhone. Look just like on an iPad, okay? But it better be small because it doesn't have a lot of room. So this is how you can control that adaptation behavior, okay? But here's a problem. Let's say you do that, okay? Let's say you don't do that. Let's say the popover is too big and it comes up full screen. How do you dismiss that popover? Okay? Because it used to be a popover, I could click somewhere else and it would disappear. But now it's full screen. I can't click anywhere else. How do I dismiss it? Okay, that's a problem. What would be really cool is if you could put it inside a navigation controller and then add a little done button, right, at the top. And this method is how you do that. So if you implement the delegate of the popover presentation controller and you implement this thing view controller for adaptive presentation style, it allows you to return a different view controller to present. For example, you might return a navigation controller whose visible view controller is the actual view controller that was inside the popover, you see? And you could add a done button to it or whatever you want. So here you can return, if you return nil here, it's going to just return the thing that was going to be inside the popover. But if you turn a navigation controller or whatever, it'll put that up in the modal adapted. And this only is happening in the adapted case, right? View controller for adaptive presentation style. Okay? All right, very important issue about popover is its size. Okay, iOS implements its size in a very object-oriented way, which is that when you have an MVC that's going to be put up as a popover, the system asks that MVC, what size would you prefer it to be? Okay, because that MVC obviously knows what the best size for it to be is. And it does that via this var called preferred content size. It's a CG size. And you can either set this preferred content size, right? The MVC can set its own preferred content size to something reasonable, or you could actually even override it and have it return its correct size, its preferred size. It's called preferred, by the way, because obviously the system will try to fit it on screen, but if, for example, it's on a horizontally compact and the adaptive thing is turned off, then it might have to jam it in there. It might have to be a little smaller than preferred wants it to be, okay? So this is not guaranteed to be the size. This is the size is preferred. Okay, the last segue I'm going to talk about is embed segues. Okay, these are really, really cool segues. Basically, you could take an MVC, take its view, you know, the top level view, and put it as a view inside the view hierarchy of another MVC. Okay, it looks just like a view in another MVC. It's just that it's completely controlled by an MVC. Okay, really cool. That's why it's called embedded. You're embedding an MVC inside of another one. Xcode makes it really easy to do this. Just go down to your little object palette down there where you get your buttons and stuff and look for container view and drag that into the place that you want this thing to be embedded. It'll look just like a view. You can do auto layout constraints on it. You can put it as a subview of anything else you want. It's just a view, okay? And when you do it, you're going to see this kind of cool look where it puts what looks like a segue thing. Okay, here's the thing. The container is what I dragged out. This segue right here, and here's the MVC. Okay, so here's a normal MVC like in your storyboard anywhere else, and it's got this little segue here. So it kind of seems like a segue, and it is in a sense going to segue to it. It's just that instead of doing it modally or something like that, it's just going to put its view right in here. Okay? Make sense? And you can prepare for that segue. It's a perfectly normal segue. One thing to be careful about this, though, is the view loading timing. Remember that when you're in prepare for segue, none of the outlets of the MVC are set, and that's true with embed as well. All right, so you might have this embed segue has all this cool UI, but none of its outlets are set up. So a lot of times in the embed, when you're preparing for an embed segue, you're just grabbing the MVC and holding onto it with a pointer. And then later, like in your own view did load, okay, your MVC will be loaded by then. Then you can go and set whatever you want to the embedded thing to look like. Okay? So just be careful of that. It's just a standard thing here that the prepare for Segue outlets aren't set in the destination MVC, but for embed, it's even more obvious. It bites you more often. Okay? So that's segues. Okay, that's all the segues there are. Okay, now you've been covered. Yeah, question?
So for the embed segues, if you have an existing view controller, can you connect it to be inside, or does it have to look funny?
Yeah, so the question is, can I connect just a regular MVC from somewhere like maybe my Cassini image view controller, for example? It's just sitting around there. Could I embed it? And the answer is, yes, you can. Okay, the MVC is embedded. There's nothing special about it whatsoever. Okay, it can be embedded just as easily. All right. Core location is my next topic. Okay, we're done with segues. Now we're moving on to core location and MapKit here. So core location and MapKit are really two pieces of the same puzzle here. Core location is the non-UI way to find out about your location. Okay, and then MapKit is the bunch of UI to show your location on maps and stuff. So we're going to talk about core location first because it has a lot of the intrinsic stuff that you need to understand the MapKit stuff. All right. The basic object in core location is called a CL location, core location. The CL location has the coordinate, latitude and longitude, altitude, the horizontal and vertical accuracy of this location, because sometimes depending on how you got this location, it might be highly accurate, within a meter or so, or it might be very inaccurate, maybe it's a kilometer, okay? A timestamp, when this thing was taken, you'll see that that's very important. A speed, if the system detected that you were moving at this time that this thing was taken. And a course will tell you what direction you were headed in if it detects that you were moving at this point. Okay? So that's the basic collection of stuff is in a CL location. The CL coordinate, this coordinate thing right here, is a CL location coordinate 2D, which is just a latitude and longitude struct. The altitude is a CL location distance, which is in meters. Okay? Now let's talk about the accuracy thing. Okay? When you are asking for a location and when you get a location, in both cases, you're going to specify an accuracy. Okay? Specifying the accuracy is going to determine what mechanism your device uses to get the accuracy. And then when you get the accuracy back, it tells you kind of how it got it, somewhat. Okay? So we're a little bit abstracting the hardware away from the concept of an accurate measurement of location. Here are the different accuracies that it can have here. Best for navigation, best, nearest 10 meters, 100 meters, kilometer, or 3 kilometers. And as you can imagine, best for navigation is really accurate. It's also really uses a lot of battery. Okay? Basically, you could almost rename these things as lots of battery usage, a little bit less, medium battery usage, not so much battery usage, very battery efficient by the time you get to the bottom. Okay? It's really, battery is a big deal when it comes to getting your location. Now, how does the system get these different accuracy locations? Well, there's 3 different ways, really, at least for now, that the system can get a location. And you don't know which one it's using. Okay? All you get to do is specify the accuracy you want, and it'll get the location as best it can and tell you what accuracy it got. But the 3 ways it knows how to do are GPS, which is very accurate and uses a lot of power. Okay? Then there's Wi-Fi nodes. Believe it or not, your phone can, as you walk around, see what Wi-Fi nodes are around. And it's got a huge database on the network of all the Wi-Fi nodes and where they are. And so based on which ones are close to you, which ones are getting good signal, it can figure out generally where you are, which is kind of a cool feature, right? Pretty low power. Wi-Fi is fairly low power. Not as low power as cellular towers, which is the next one, but certainly a lot less power than doing GPS. And so it can find, these kind of medium accuracies by doing that. And in fact, you walk around at Stanford, it can be very accurate because there's an incredible number of Wi-Fi nodes around Stanford campus. You're probably in range of 50 of them at almost any time, certainly 20. So it pretty much knows almost exactly where you are. And then the last one is cell tower triangulation. Okay, same way with the Wi-Fi nodes, it can look around to the cell towers. Now, there's a lot fewer cell towers than there are Wi-Fi nodes, okay, and they tend to be farther away from you. Okay, so triangulating them is a little more iffy. Okay, and sometimes there's not one for very, very far distance from you, kilometer or more. So that's why you start getting these really low accuracies out here. But the cellular radio is incredibly low power, super, super low power. Okay, and your cellular radio is also automatically being turned on and off and used as you walk around and you're making phone calls or receiving phone calls, et cetera. So the cellular infrastructure is very low power, but low accuracy. Okay, got all that? All right, there's other things you can find out in the core location, the speed, your course, that timestamp. The reason the timestamp is important is there are a lot of ways to ask the system to give you CL locations, not in real time. In other words, it's not going to give you the location right now. Like you might be going out for a run and you put your phone in your pocket and it goes to sleep, it can still collect locations. And then when it wakes back up, it'll send them all to you. And when it does, you're going to want to know the timestamps so you knew where you were at the time. So timestamp is an important part of the CL location. All right, so how do we get a CL location? Well, you get it from a CL location manager usually. Just like we had core motion, we have the CM motion manager. Well, the core location, we have the CL location manager. And it has a delegate that's going to generally give you locations. What's really cool about it is you can actually test in the simulator by simulating yourself being in different locations. If you go down near the debugger bar, there's a little guy there. And you can even upload with the GPX file. A GPX file is just a file with a bunch of waypoints in it. Okay, GPS locations can have other stuff in there, like actually URLs for photos taken at the location, stuff like that. But it can have these locations. You can upload it and have whatever testing you want in here. Okay. So the CL Location Manager, how do you use it? Similar to the CM Motion Manager. First, you're going to check to see what hardware is available. Okay. Then you're going to create a CL Location Manager and set its delegate so that you can receive updates. Then you're going to configure the manager to say what kind of location you want. And we'll talk about what that means. And then you're going to start it going. And once you start it going, it's going to start sending you locations based on what you asked for. All right. What kind of location monitoring is available in the system? Well, one is accuracy-based continual updates. This is what you would normally think. You set an accuracy that you want. Okay, I want highly accurate, best for navigation, or low accuracy. And the system will start sending you locations based on that accuracy. So if you ask for best for navigation, it's going to be sending you locations all the time, and they're going to be highly accurate. If you ask for every 3 kilometers, you could walk for 20 minutes before it sends you another location, because it notices another cell tower and can figure out its location. Okay? So that's one way to do it. Another way is you can get notified only when a significant location change happens. Okay? This is basically, I'm not talking about how it's implemented here, but it kind of am, but it's basically when it sees a new cell tower. Okay? So that's a significant enough change that it'll probably send you one. So this is not highly accurate locations necessarily. Okay? Another one is region-based updates. So that's, you can define these regions, either little circular areas in the world or even where beacons live, okay, little Bluetooth beacons. And you can get notified when you get close to that beacon, or you get real close to the beacon, or when you walk inside this circular area. Okay? And then you also can have your heading monitored. If you change direction, it can send you a new location. All right. So let's talk about how we use CL Location Manager, and then we'll talk about how to make each of those things work. First, we want to find out what our hardware can do. One of the most important things to find out about hardware is whether you're authorized to get the user's location. As you can imagine, users might not want you to know where they are, tracking their every move out there. It's kind of a sensitive subject, okay? So you have to make sure you're authorized to receive it. And you can do this with these various things. I'll talk about in detail authorization on the next page. By the way, anytime you have an authorization status of any kind, not just for location, you notice there's the states authorized, denied, or restricted. What restricted means right there is it's denied and the user can't change it. So don't put up an alert that says, oh, I'm not authorized to get your location. Please go to settings and change it. Okay, because they're not allowed to. There are ways in enterprises inside companies where companies can configure the phones of their employees so that, for example, they can't do this location service or other services. Okay, so be careful about the restricted state. That if it's restricted, just accept the fact you can't do it. All right. And then you can also check for certain kinds of monitoring, like can you monitor for beacons or can you monitor for circular regions. Most new hardware can do all of this stuff, but if you have an older phone, maybe it doesn't have some of the capabilities to do that. All right, so let's talk about this authorization piece though, because it's a very important, interesting piece to do it. There's a couple of steps you have to do to make it work. One is you have to request authorization, okay? This is asynchronous, okay? You send this to the CL Location Manager, and you're going to request one of these two different kinds of authorizations: in-use authorization or always authorization. So in-use authorization means you only want to be allowed to get the user's location when it's the foreground app and the user's using it. Okay? When the user's in the background or anything else, you can't find his location. Users are fairly comfortable with that level of authorization because they know when you're getting their location. Always authorization is you can get their location anytime, even in the background. And that's very invasive of their privacy. So, you know, a lot of people, users won't do this. They won't give you that authorization. Okay? So the system might be putting up an alert asking the user if it's okay. They're checking in their settings to see what settings are there, things like that, to find out. So that's why it's asynchronous. Eventually, a delegate method will be called in your CL location saying, okay, here's your authorization status. It was denied, or it was allowed. Okay? Now, when you go off to request this authorization, you have to have the user in their settings. If they go into settings and look at location services, your app will be there. There has to be a switch they can click that says, yes, I'll allow this app to have always authorization or in-use authorization. To put that UI in the settings, you have to put something in your info P list, okay? Which is this key right here, NS location when in use description, or NS location always usage description. This is a string explaining why you want this particular authorization. And if this key exists, then in settings, the user will be able to have a switch to turn this on or off. So if you don't put these in here, these things on top, these funcs, will always fail because there's no way for the users to set that in their settings. So they'll just always fail. Okay? And the system can't put up an alert even asking if it's okay, because if they said yes, there's no way, no switch for the system to turn on. So it'd just be always denied. So you need these two steps to get authorization. All right. Now, how do you then get the CL location from the location manager? Of course, you can poll, but like with Motion Manager, we say that's not a good idea, but you can do it. You can't just ask the location manager, please give me the current location, and it'll give you the location with whatever accuracy it has. Okay? But really the way we do it is we set this var in the location manager called desired accuracy. That's one of those accuracies like best for navigation, all those things. And then also a distance filter, which is how far the user has to move before we're going to give them a new location. Okay? So if you take 10 meters, the user's got to walk 10 meters down the way before another location will come. And those two things together will give the system a good idea of how hard it has to work to get the user's location. Okay? So you set those, and then you say start updating location. And as soon as you say start updating location, as long as you've set these, you're going to start getting locations appropriate to these settings up here. Okay? Now, be sure, just like with the Motion Manager, in fact, even more importantly than the Motion Manager, to stop them when you're not going to do anything with the results. If locations are coming and you're ignoring them, you should have stopped it. Because this is basically turn on battery save, okay? If you don't if you don't stop updating location, you're not using it, you're just draining their battery for nothing. It's probably the number one way to drain their battery, actually, okay? And people will rapidly, you'll get it on your app store thing, and the comments it'll say, drains your battery, don't buy this thing, okay? So you want to be really careful not to do that. Okay? So once you turn it on, you're going to start getting this delegate method sent to you. Did update locations is plural, which with an array of locations. Now, why is that an array of locations instead of just sending you each location one by one? Well, it's that running example. You go out for a run, your phone goes to sleep, it collects a bunch of locations, and I'm not going to talk about how you set that up, but you can look in the documentation. And when you pick your phone up at the end and say, oh, how was my run? Boom, you're going to get all these locations as an array here. Okay, with timestamps and all that, so you'll be able to reconstruct the run. Okay, similar API is this for heading, if you want to just monitor the user's heading. Error reporting is important and easy to miss because you have to implement another delegate method here, which is location manager did fail with error, but you definitely do want to be looking at this. Okay, if you are using a location, you have to implement this. Because, for example, the user could at any time go to their settings and say, no, I don't want this guy using my location. In which case, you're going to start getting this denied. And if you don't look for this, your app is just going to go in some wacky state because it's not going to know what's happening. Okay, you need to know what's happening. Also, error location unknown. If for some reason we can't find the location, maybe you ask for best for navigation, and it just can't find any thing to give you your location. So you want to know that as well. Okay, so you definitely want to look at this thing. If you're doing location manager in your final project, you got to implement this. Okay. All right, let's talk about getting your location in the background versus about getting your location in the foreground. Okay, so when you get in the foreground, it's all the things we just talked about. There's a bird in here with us. When you're in the background, though, things are a little different because you know that generally you're not allowed to run in the background. You kind of go quiet and then you get no cycles. But there are ways. Remember when we went and enabled iCloud in that capabilities thing? Well, there's things in there where you can enable backgrounding for locations. Okay? Now, if you do this, you will continue to get stuff in the background. You can imagine it's even more important to be sure you're not sucking the battery in this situation. Okay? And this is the kind of thing where if you're sucking the battery in the background there, your App Store app might not get approved. Okay? That's how important it is not to be sitting there sucking the battery in the background. Okay? Now, there are other ways, though, very battery efficient ways to get your location in the background. So let's talk about those. One is that significant monitoring thing I was telling you about, where you're walking around and it notices a new cell tower, so it's very kind of large grained. That's an awesome way to get locations for very low battery. It uses almost no battery to do this. And what's more and really cool about it, if your app is in the background, you'll get the notification. If it's not even running, it will get launched and told this information. So this is a very powerful telling you where the location is. And when it gets launched, by the way, if they're using some other app, it will launch it and launch you in the background. So you can figure out where you are and decide if you need to do something. Okay, so this one was really cool, really low power. The only problem with it, it's large grained. Now, once you get woken up that you significantly changed, you could start doing more close location, okay, GPS location, try and find out a little bit exactly where you are if you want. Although be careful not to take too long when you get launched for this in the background, because the system will stop doing this if you starts consuming a lot of resources in the background there. Okay, so be careful with that. Similarly is the region-based monitoring. Okay, where you specify a circle or beacons, okay? That also will wake you up and even launch your application if it notices you going into that region, okay, and run you in the background. Also low power, really nice way to do it. So if that will meet your needs as well, that's a good one to do. Okay, when you enter a region, either a beacon or circular region, you're going to get these delegate methods: did enter region, did exit region, and monitoring did fail for region. Also, there's the error handler for that one. Okay, so that's kind of a fun one. Region monitoring works when you're not running because all your regions are named. Okay, they all have to have unique names, and so when you get launched, you'll know which one fired by its name. There's by the way, a maximum limit to the circular region called maximum region monitoring distance. You want to look at that. You can't say, when I enter the United States, okay, that won't take that big of a region. It has to be much, much smaller. This will tell you how big it can be. Okay, this is the beacon thing. When you're looking for beacons, what you're really interested in is how far from the beacon am I? Okay, am I close to it, like really, really like next to it, or a little bit far away, or across the ways? So beacons are used for things like you go into a coffee shop, and when you get right up to the register, maybe it offers you a coupon or something like that. Well, it needs to know you're right near the register. But maybe when you just walk in the store, it just gives you an advertisement or directs you to some display. Okay, so the beacon would be sitting maybe near the register, and so this thing is telling you. So that's why we call it ranging. Start ranging these beacons. Now these beacons could be other iOS devices, can serve as a beacon, okay? Or you can even buy these third-party standalone iBeacons, basically, that'll act as beacons. If you wanted to be a beacon, okay? That's beyond the scope of this class. I can't really tell you how to do that, okay? You need to get the core Bluetooth framework involved here and check out CB Peripheral Manager. It'll show you how to do it. But it's a little more complicated than I can show in a couple slides. So that's it for core location. Let's now talk about MapKit, which is the UI way of showing location. MKMapView is a UI view that displays a map. Okay, it looks just like the Maps app on iOS. A map can have annotations, like this little red pin down there. Okay, each annotation has a coordinate, obviously the GPS location where that thing is, and also a title and a subtitle. Okay, there's no subtitle shown in this one right here. Okay. The annotations, though, can also have this call-out, this white area. That's not part of the annotation view. That's a call-out that the annotation view brings up. And so we're going to talk about the components of this call-out in a second as well. Actually, let's talk about it right now. It's got a left accessory view and a right accessory view. And these are usually things like UI image views or maybe UI buttons, things like that. Okay? So this is how we're going to build our map UIs out of these components. So how do you create a map view? Really easy. MKMapView, okay, or MKMapView with a frame initializer, or you can drag it out in your storyboard, which is what we'll do in the demo. A map view, how does it basically work? It's got an array, this var annotations, which is an array of MK annotation. Okay? MK annotation is not a class, it's a protocol. So anything could be an annotation on a map as long as it implements this protocol. What is that protocol? It has coordinate, title, and subtitle. Okay? If you implement those three vars, boom, you can be thrown onto a map. You will be an MK annotation. They're all get, see? Var title is an optional string, by the way, but it's really expected to be implemented. Don't ever leave this nil, or system does not like that. Okay? I'm not sure why it's optional. Shouldn't be. And then the core location, this coordinate, remember that's the CL location coordinate 2D, latitude and longitude. Okay? So that's it. So it's got this array of annotations, but you notice this array is read-only. So to add annotations or remove annotations, you have to use these methods, add and remove annotations. Okay? It's generally a good idea from a performance perspective to add all of your annotations that you know about up front. And that's because the annotation views, those little pins, get reused just like in a table view. Okay? So you might as well add them all up front and let the system reuse the pins as you scroll around the world. Okay, it can reuse them. What do annotations look like on the map? Well, we saw it before, right? If you use an MK pin annotation view, which is a subclass of MKAnnotationView, you get a little pin. It can be red or purple, I think, or maybe one other color. Although it does allow you to even change this image. If you don't like a pin, you can change it to something else. And when you click on a pin annotation view, you get this call out, and that's what the call out looks like. Okay? So what happens when you press the pin besides this call out coming out? By the way, this call out only comes out if can show call out is true on the MK annotation pin annotation view. Okay, so you have to have that be true. So this will come up, but in addition to this appearing, a delegate method will be sent to the map view's delegate. It's called MapView did select annotation view. Okay? And so this is an important little method right here because if you're going to show anything expensive in your call out, like so you're going to go over the network and grab an image or something like that, you're going to want to wait to do it till did select annotation view because if the user never clicks on this pin, you're never going to see that image, so you don't want to waste your time fetching it. Okay? So this is a place where you're going to do expensive stuff that's going to show in the call out. You also, though, might segue out of this. When someone clicks on a pin, maybe you want to go segue to some other view. I don't know. Okay, but this is the target action of MK annotations. All right, so how are these annotation views, these little pins, created and associated with those annotations? Because we know MKMapView only has this array of annotations. So how do those pins get there to show them? And the answer is from this delegate method right here, MapView view for annotation. This is very much like self-heroic index path in table view. Okay? So in there, you're creating a cell, which is a view, okay, UI table view cell. Here you're creating an MKAnnotationView, like the pin annotation view. Okay, so let's go through this and see how we do it. First, we're going to dequeue a reusable one using some identifier. But if that fails, okay, and view is nil, if we can't dequeue one, then there's no prototype like there is in the table view. So we have to create the prototype in code. So here I'm creating the prototype by saying view equals MKPinAnnotationView. Okay, but I'm specifying that same reuse identifier that later I might come back and do this reusable with, you see? So that's how they get done. And then can show call out, either set to true or false, whichever one you want. Okay? Then we're going to, whether we created the view or not, we're going to want to set the view's annotation to be the annotation we're creating this view for. Okay? And then we're going to want to prepare this view with anything else. Like if it's going to have a left call out accessory view, which is an image view, this is the time we would add the image view. This might not be the time we actually go fetch the image to put there. We might wait until did select annotation view to do that. But we're going to want to put the UI image view in there so that it's ready to go in the call out. Okay? And then we're going to return the view. And then the system's going to use this view to show that pin. Okay, interesting properties on UI annotation view. We already talked about the left and right call out accessory views, which are just views. There's also whether it's enabled or not. This image is the image of the pin, not the image that's in the call out. This is the image of the pin. Also, you can make it draggable, setting draggable to true. If you do that, your MK annotations, the coordinate property would have to be get and set. Obviously, if you're going to drag it around, you have to be able to set the property as well. Okay? This cool property or delegate method right here, call out accessory control tapped, will get sent to your MapView delegate if your left or right call out accessory is a UI control, basically a UI button. Okay? So if you put a button as your left or right call out accessory, when it gets touched, you're going to get this call out accessory control tapped method, which is pretty cool. In did select annotation view, we talked about the fact that this is where you might want to create your image or even fire off a thread or queue on a different queue, fire off a request to go get the image. When it comes back later, you'll have to load it up into the accessory view. Okay? Just like when you're scrolling around in a table view, realize that if you're scrolling around on the map, you might fire off a dispatch async here to go get this image, and when it comes back, that image is no longer being displayed in this call out accessory view because it gets reused, right, by other ones. So be careful about that. The map, you can configure the way it displays. This is a var on MKMapView. You can do standard, satellite, or hybrid. So standard is like streets and things like that. Satellite is like Google Earth type thing. And then hybrid is a mix, an overlay of those two things. You can also show the user's current location on the map just by saying this bool to true, and it'll show it. I think the user's current location is blue, or maybe it's purple, I don't know. But it'll just show on there. You can also get the user's location as well as an MK user location, which is just a thing that implements the MK annotation protocol. You can also restrict scrolling. Okay, maybe you don't want the 3D mode. If you don't want 3D mode, set pitch enable to false, and it won't pitch up to show you 3D maps. You can control the camera. If you do allow 3D, you can control where the camera is pointing using this API right here. That's kind of fun. You can also say what part of the world is being shown with this MK coordinate region, which is just a latitude, longitude, and a span, okay, which is a number of meters. Okay, so it shows that, it'll show that part of the Earth. Actually, it's not even meters. The span is a delta of latitude and longitude, how many degrees of latitude and how many degrees of longitude to show. Okay? What else we can do here? I just want you to note that there's a whole bunch of C-like functions, okay? They're Swift global functions. They're not methods that you can do to convert like from map coordinates to view coordinates and things like that. So make sure you take a look at these and understand all these. There's probably about 15 or 20 of them that will help you do conversions. There are also some methods that will do it as well in MKMapView. There's a cool method in MKMapView called didChangeRegionAnimated. Okay, so if you tell the map view to show a different part of the world, like New York, okay, it's going to animate going there. It's going to scroll over there. But if I'm in San Francisco and I say show New York, it's going to go, okay? You're not even going to see it. In Nebraska, you'll never see it, okay? Nebraska can go by so fast, you'll never see it. What would be really cool is if you said, I'm in San Francisco, show New York. First you said, show the whole United States, then show New York, right? Then you get this cool animation. San Francisco to the whole United States down to New York. Wouldn't that be cool? Yes, it would. And so the way you do that is you, first of all, set your location to the whole United States, or middle of the United States with a large span, and it'll go up to there. And as soon as the animation of that finishes, you'll get sent this. Okay, because it said it did change region, it finished the change region. As soon as it sends you this, now you animate to New York. So you're essentially chaining, you see? And now it'll animate down New York. So this is a way you can chain animations to make the animations kind of fly around the world nicely. MKLocalSearch, I'm not going to really talk about it, but it's a way that you can put, you know, normal English language descriptions of places like Ike's, and it'll go and search. This is asynchronous because it's going to go out on the internet to look this up, but it'll come back and give you a bunch of locations that might match this search. Okay. Similarly, you can ask for directions. You can say, I want to go from here to here, and I'm going to drive. Give me directions, and it'll give you this thing called an MK route, which will have turn-by-turn directions, and also have an MK polyline, which is an object which will draw this blue line right here. Okay? And how do you get this blue line showing on here? You're going to use another feature called overlays. Okay? Overlays are very much like annotations, but instead of you have view for annotation, you have overlay view for annotation, okay, renderer for annotation. Okay, and this renderer could be something like a polyline renderer. And if you have a polyline renderer and you give it an MK polyline that comes from that root thing, you can draw that root. Okay, you can also use overlays for your own thing. If you want to draw a bounding area around something, or you want to draw your own path of where you went, you can do all that with overlays. Okay, if you want to do that in your final project, it'll count as not covered in lecture because I'm not really covering it. I'm just telling it's there. Okay, same thing with local search and all these things I kind of glossed over here. Okay, these are some of the built-in renderers, polyline, also circles, polygons, tiling, etc. Okay, so that's it. Now we're going to start a demo that's going to last across both lectures here. And we're going to start by just doing a simple app that takes some waypoints and throws them on a map. So we can see how to do that. Also on Wednesday, in addition to finishing up this demo, I'm going to cover the last topic of the quarter, which is persistence, which is basically how to store things in the file system, right? Opening files and all that business. Okay, so let's go start a new app here. We're going to create a brand new one. It's an iOS app, single view as usual. We'll call this one Tracks, okay, because it's going to keep track of where you have been. We'll make it a universal app, so it works on iPhone and iPad. There we go. We'll put it in our standard location. All right, so here's Tracks, the storyboard right here. I'm going to do my standard thing. We're going to move some of these things off to supporting files here. Supporting files. We're not going to be needing to do anything in app delegate, so I'll move it off to supporting files here. In my storyboard, I actually don't want my view controller here to be called generic view controller, so I'm going to rename it to be GPX view controller, because what we're going to do is take a GPX file, which, like I said before, is just a file that contains a bunch of GPS coordinates, and we're going to put it on our map. So we're going to call this our GPX view controller. So I'm going to rename it here as well, and also in my storyboard. We go here to the identity inspector, change this to GPX view controller. Okay. Now, let's also go ahead and build our UI here. Our UI is going to be all map all the time. Okay, our entire UI is just going to be a gigantic map. So I'm going to go down to my object palette down here and try and find map. Actually, I'm going to search for it by just typing map. Here it is, a MapKit view. I'm going to drag that out and put it here. Make it fill the entire MVCs scene. Of course, we'll do reset to suggested constraints. And we'll jump over here to our size inspector and make sure it did the right thing. Sure, it looks like it did. Let's go ahead and make an outlet to this from our controller. So I'm just going to control drag in here. I'll call it my map view. Okay, you can see that it's a type MKMapView right there. So we have our map view. Let's go ahead and when our map view is set, let's go ahead and configure our map view what we want it to look like. So how about the map view's map type? Oh, and see, it's not doing escape completion here. Why not? Import MapKit. Okay, just like CloudKit, it's a separate framework. We need it, or it's not going to know any of these types. So let's set our map type to be satellite. Okay, satellite images. Let's set our delegate. Of course, nothing works in a map view without a delegate, so we absolutely have to be its delegate, and that means we'll have to be an MKMapView delegate. All right, so we have our map view set up here nicely. Oops. Okay, so now we need our model. What's going to be our model to this thing? It's going to be a GPX URL. Okay, so this is going to be the URL to a GPX file, a file that contains coordinates. And we're just going to open that file, look at all its GPX coordinates, and display them. And in fact, let's go ahead and in our view did load here, just load one up. So let's see, GPX URL equals, how about this one right here, string, which is http cs193p.stanford.edu/vacation. Oops, vacation.gpx. Okay, so that's just a URL I have around there that we can look at. Now, this is an HTTP, so we better go over to our info.p list right here and do the thing we always do here where we add our app transport settings right here. Let's add arbitrary loads allowed, and we will say yes. Everyone understand why we're doing that? Same thing we had to do with smash tag there. All right, so we're all set up here. What are we going to do when this is set? Okay, so when our model is set, when this URL is set, what are we going to need to do here to make this work? Well, if they set the URL equal to something, so they didn't set it to be nil, let's say, then what I need to do is parse this file, this URL somehow. And to do that, I'm going to introduce a little class that I wrote called GPX, which will parse a GPX file and then give you all the waypoints. Okay, so let's go ahead and grab that file. It's right here. It's called gpx.swift. Copy it in. Take a brief look at this thing, what it does. All right, here's GPX. Let's go ahead and look at it just at its generated interface here. I need to look at the code there. All right, so here's the GPX, this class. And the main thing it has is this var waypoints, which is a array of GPX waypoint. Let's go look at the GPX waypoint. That's right here. So the waypoint is latitude and longitude, of course. Kind of some information about this waypoint, the date the waypoint was captured. And it's also an entry. This waypoint is also an entry, which is this thing. The entry can have any number of hyperlinks. So these would be like URLs to photos or video that I might have taken at this location when I was on my trek or whatever. Also, it has a name, which is the name of this waypoint. Okay, may or may not have a name, but if it does, this is the name. Okay, these links, by the way, these GPX links is right here. It's basically just URLs, hrefs here. Okay. All right, so that's it. That's all this thing does. The main thing is this array of waypoints. Okay, so let's go back to our controller here. So we do this GPS parse. Notice that this parse method in GPX is asynchronous. It parses that file, and then later it calls you back. It's a very nice asynchronous method in that it always calls you back on the main queue. Okay, so we don't have to dispatch async or anything here. And the only argument that's given when you do it is a GPX, which is an instance of this class, and it has those waypoints. Okay, so what are we going to do with these waypoints when they come back? Well, if it was able to parse it, basically if this thing came back and it wasn't nil, then we're going to add these waypoints to ourself. Waypoints. Okay, so we're going to have to do this method here. Also, every time someone said it, I'm also going to clear any waypoints that I already have. So I'm going to implement these two methods right here. Okay, everybody cool with that? So we're just getting those GPS waypoints out of this GPX file. So we got to implement these two methods. So let's do private func clear waypoints. Okay, so for clear waypoints, I just want to remove all the annotations off my map. Remember, the map just shows annotations, so I'm going to remove them all. So I'm going to say MapView, remove annotations, which is the map view's current annotations. Okay, whatever the map view currently has. Notice I'm doing this map view question mark here. That's because if this happens in like a prepare for segue or something like that, then my map view wouldn't be wired up yet, so I don't want this to fail. I just want it to do nothing. So that's why I'm doing map view question mark. Okay, and then we have the add waypoints, private func add waypoints. And this one is going to take an array waypoints, which is an array of these gpx.waypoint objects. Okay, so what do we want to do in add waypoints? Well, we just want to add them as annotations. So I'm just going to say add annotations, these waypoints. Right, map view. Another thing I'm going to do is there's a way in the map view to say show me all of these annotations. You say show annotations, and it takes some annotations, and I'll just give it those same waypoints. And I'll say animated true. And what this will do is zoom the map to show these annotations. Okay? Now, couple errors here. What are these errors? Cannot convert value of array of GPX waypoint to expected argument, which is array of MK annotation. Right? I said that the map view takes MK annotations, and these are GPX waypoints. They're not MK annotations. But we can easily turn a GPX waypoint into an MK annotation as long as we get it to implement those three methods, right? So how are we going to do that? Well, let's create another little file, and we're just going to add protocol conformance via an extension, which I talked about early in the quarter, but we haven't seen it actually happen. So here I'm going to create a Swift file. I'm going to call it MKGPX because it's MKAnnotationView stuff having to do with this GPX class right here. And I'm going to import MapKit. MapKit. All right, and what am I going to do? I'm going to create an extension to gpx.waypoint, and it's going to implement the protocol MKAnnotation. That's what this extension is going to do. So this is how we can implement a protocol via an extension. Okay, now all we need to do is implement these things. Remember, there's coordinate that we have to do, which is a CL location coordinate 2D. We have to implement title, which is a string, optional, but we have to implement it. And then there's subtitle, which can be any subtitle information we want, okay, which is also a string. So we just have to implement these three things, and then we will have successfully added the MK annotation conformance to waypoint. So how are we going to implement these things? Okay, well, coordinate, this is not coordination, this is coordinate, okay? The coordinate is easy to implement because the GPX waypoint knows latitude and longitude. So I'm just going to create a new location coordinate 2D, okay? And it's going to have latitude, which is the latitude. It's green there, you see, because it's a var in this class. And then longitude. Okay, so that was easy. How about the title? Well, all these GPX waypoints have that name, so I'm just going to return the name of the GPX waypoint. And then they also have this thing called info, which is just kind of information about the waypoint. That would be a good subtitle. Okay, so just like that, I've turned GPX waypoints into MK annotations. And this is how you use the map. You take usually something you already have and make it implement this. Now you could create a new class that all it does is implement MK annotation. That's fine too. But generally you usually have something lying around that you can turn into an MK annotation. And notice as soon as I do that, no more errors here. Okay? Because this is now an array of MK annotation. Okay? All right, so let's go ahead and run this. See what happens. Let's go here, iPhone 6. Run, see if it can open this GPX file up and show us these waypoints. Sure enough, there it is. And it even did that show annotations right here, okay? That zoomed to where it is, so it's showing all the annotations it found in that GPX file. Let's see if we can see where we are here. We'll zoom out. Looks like we are in Anyone know where that is? Recognize that coastline? Canada. Yeah, there's the United States, here's Canada. Okay, so here we are, we got these things in Canada. Now if we click on some of these, let's click on some, see what happens. So I click, notice we get the name and the info, right? The title and the subtitle. Got it? Now I happen to know that this GPX file has URLs of photos that were taken at all of these locations, okay? So the next thing we'd like to do is see those, okay? And what I'm going to try and do is put them as a thumbnail image inside my left accessory view of these callouts. Now, to do that, we're going to need to override or implement that method view for annotation. Notice that we didn't implement view for annotation, which is like self-heroic index path. And when you don't, you get this really simple callout that has no left or right accessory view, it just has the title and subtitle. Okay? But we need to implement it so we can put a left accessory view, which is going to be a button. I'm going to have it be a button because I'm going to want to be able to click on it and segue to show me the image later in the demo, probably next lecture. All right. So how are we going to do this? Well, we have to implement that method view for annotation. So see if we can find it. There it is. Okay, MKMapView for annotation. Okay, it's asking us to provide an annotation view for this annotation. So first, I'm going to see if I can get it. And I'm actually going to do something kind of interesting here. I'm going to type this. Now, normally you would say, oh, why are you putting a type here? Because you could just say view equals something and it would automatically infer the type. Well, the reason is because I want it to be implicitly unwrapped. Okay, if I didn't put this here, okay, then it would be an optional because the thing I'm going to call returns an optional. But I want it implicitly unwrapped so the rest of my method looks nice, the code in the rest of my method. Okay, so what am I going to do here? I'm going to ask the map view to dequeue a reusable annotation view with an identifier. Now, to be nice, I have some constants. Let's put them at the bottom here. Okay, so here's my constants that I have, and I have a constant for the reuse identifier here. Call it waypoint. So I'm going to go here and say constants.annotation reuse identifier. Okay, so that's dequeuing it. Now, what if this is the first pin it's ever doing? It's not going to be able to dequeue. There's no pins to reuse. There's none that were used and now left over. So now we're going to have to say if the view equals nil, we have to create this thing because there's no prototypes like table view. So I'm going to create the thing by saying I want an MKPin annotation view, and the arguments to initializer here are the annotation, which is this annotation right here. That's the annotation we're creating a view for. And we want to use the same reuse identifier right here because in future we want this one that we're creating to be in the reuse queue. Okay? And I'm also going to say that we can show callouts. Okay, because by default, I believe if you create an MKPin annotation view, it won't show the callouts when you click on it. So I want to make sure it does show the callouts because that's where my left accessory view is going to be. Otherwise, if I was able to dequeue one here, then I need to change the annotation in it to be this annotation here. Okay? All right, now we've got this view. This is basically exactly what's happening if we don't implement this method. Okay? And in fact, if I run this, if I just return this view and run it, you're going to see it looks exactly the same. Okay? The system basically will do exactly this for you, see, if you don't implement it. Okay? So it's doing exactly the same thing. So now let's add this left annotation view, which wants to be a UI button. So how are we going to do that? Okay, well, let's just first of all, let's set the left callout on accessory view to be nil because I'm only going to put this little button in there if the GPS waypoint has a photo. If it doesn't have a thumbnail image, I don't want that button to be there empty. So first of all, I'm going to clear it out. Okay, then I'm going to say if I can get the waypoint, which I always should be able to because it's just the annotation as a GPX waypoint, right? That's what the waypoint is, this annotation. All of our annotations are that. So as long as I'm able to get that waypoint, which I should be able to, then I'm going to, if the waypoint has a thumbnail URL, if that doesn't equal nil, now this is something I'm going to have to implement, okay, because it doesn't have that method, so I'm going to have to implement that method. Then I'm going to set my left callout accessory view to be a UI button. whose frame is this constant. Unfortunately, I have to do a constant here for this, and I'll show you that in a second. The constant for this is 59 by 59. This is one of the few cases in iOS where you're going to use a magic number. But unfortunately, there just doesn't seem to be any way, at least that I've ever found, to ask the MapView's annotation view, how big is your call out, so that I can make the thing the right size. So I just know that 59 by 59 works. I hope Apple doesn't change the size of that call out in the future, because it might break this code. That's why you never want magic numbers, but unfortunately we're kind of stuck with one here. So we have this error because thumbnail URL is not implemented. So how are we going to implement thumbnail URL? Well, I told you that every GPX waypoint can have a number of links associated with. One of them might be a thumbnail URL. So I'm going to go back to my MKGPX right here, and I'm going to add this var thumbnail URL, which is going to be an NS URL, and it's going to be optional because it might be that it doesn't have one, which is fine. I just won't show this little side button. And to implement this, I'm going to implement a little method here, a private func, which goes through the links and tries to find one of the type thumbnail. So it's going to be called getImageURL of type. It's going to take a certain type, which is just a string like thumbnail or something like that. And it's going to return an NS URL, possibly, if it can find such a thing. And I'm just going to go through the links in the GPX waypoint, and if the links type equals the type I'm asking for, then I'm just going to return the links URL. And if I can't do any of that, I'll return nil. Okay, so this gets an image URL of type. So here I'm going to get the image URL of type, thumbnail. So if it's able to get a thumbnail image, woohoo, we're good to go. Otherwise, it'll just be returning nil here. While I'm here, I'm going to have another one called image URL, which gets the URL of the image large. Okay, not a thumbnail of it, but a big, large image of it. And so that's the type large. Okay, so these are just types associated with that link in the GPX file. Okay, so now we have these. We can go back here and do this. Now, notice that we create this left callout accessory view here. Actually, I'm going to give some space. But we don't actually set the button's image. And I'm not going to set that image until the user clicks on me. Okay? As soon as they click on my pin annotation view and the call accessory view is going to come up, then I'm going to get the image. Because getting the image is going to be expensive, because I'm going to go get it off the internet somewhere. Okay? So let's do that. And we do that in this method here called didSelectAnnotationView. Okay, it's a MapView delegate method here. It tells us when this annotation view was selected. And so I'm going to have to extract some things here, like I need to get that thumbnail image button from the left accessory view. That's just my left callout accessory view. And it better be a UI button. So that's why I'm doing if let here. I'm also going to get the URL, which is the GPX waypoint, which is the annotation as a GPX waypoint. Okay, it's its thumbnail URL, that method we just implemented. Okay, I also need to get the image data. Now I'm going to be a really bad man here, and I'm going to do this on the main queue. Okay, blocks main queue. You would never do this in your final projects, for example, okay? And now I'm going to get the UI image that corresponds to that data. Oops, image data. All right, so now I've run the gauntlet of all of these if-lets, and I have the image, and I have the thumbnail image button, so I'm just going to say thumbnail image button dot set image to be that image. For the state, remember buttons have different states, like highlighted state and whatever, so I want the normal state, which is kind of the default state. Okay, so let's go ahead and run that. All right, here we go. We'll click on it, and sure enough, now we're getting this thumbnail in here. See that? Okay, so that's all we had time for today. What we're going to do next time is I'm going to click on this button, and we're going to segue to the image view controller we have in Cassini. Okay, it's going to segue and show us the full-size image, the large image of that thing. Okay, So we'll see how Segue, then we'll go on and do some more stuff to show off some other little features. All right, so see you next time.
For more, please visit us at stanford.edu.